This is a Chrome extension built to curate or rather modify the Twitter timeline just by giving a natural language command in the pop-up of the browser. Um, it has manifest.json file. It is obvious because it is a Chrome extension. Next, coming to the logo and styles.css. This is just making the pop-up look more beautiful. Pop-up.js and HTML are the basic foundation of the extension. And coming to the brain of the extension, it lies in content.js, but content.js has an attention ranker, which is the Python file which is being showed here. This is the main brain of the extension. This is how the posts will be classified, and the relevant ones will be sent back to content.js file. So how do I do, or what, let me go through this file, because this is the most gnarly or complex thing in my entire code base, and let us start. So the first thing is, when I initialize the ranker, I create random embeddings for 5000 words in this vocab size. Okay, and then each word is represented as a 128 dimensional vector. After that, the query vector represents what the user is interested in, for example, tech, Twitter, or sports, or politics, or whatever. Then the scale factor, this last thing, the scale factor, this prevents the number from getting too large because it is being computed with attention. The second function is tokenization. It is nothing but hashing words instead of storing the entire vocabulary dictionary. So each word is assigned a token ID somewhere between 0 to 4999 randomly, so that I can store it in a more efficient manner. Third function is compute attention. This is the main mode. Uh, this is the core attention mechanism. It has the same math as transformers. So what I do is, first I compute the attention scores by taking the dot product of each word by each word's embedding with the query vector here, and then scale it to the square root of 128 in order to normalize it. After that, I apply this softmax scores. This helps me get the attention weights between 0 and 1, and more the relevant word, and it tells me how relevant each word is. So words more similar to the query get higher weights, simple as that. After that, the context vector. Now the context vector is created by taking a weighted sum of all word embeddings using these attention weights. This context vector represents the meaning of the post, focusing on most relevant words. So this is a kind of result of this entire function, or the purpose of this entire compute attention function. Next, coming to the score context, this is actually putting the previous two functions, that is tokenization and compute attention functions, results together. What I do is, in this in the second function, I tokenize the post and get embeddings. In the third one, I compute attention to get a context vector. Then I will score that context vector against my query using cosine similarity in this function. Okay, what happens is, the final score tells me how relevant a post is, or what the user is actually looking for. This is just polishing the formula. And the last one is update interests. This is simple. The name itself states that if a user has already applied a filter of showing only tech Twitter, he can choose to remove or simultaneously add another filter to show politics and tech Twitter, or sports, or whatever he likes of his choice. So this is all about it.